Good afternoon or good evening, everyone. Actually, it is good evening. It is my turn to present today on true science and naive science. Now, I just want to move straight to the topic because, as I mentioned, that we don't have much time to go through this everything. Here, I have begun the concept of synthesis paper. Which I have shared. That's why I don't want to go on this. I just want to mention here that I have put a question mark here. Here I have identified two categories of synthesis work. One is explanatory and another is argumentative. At the end of this presentation, if you tell me which kind of this synthesis work I have done, I will be very happy. That's why I have shared it. And these are the three questions I will be seeking answer. For that, I have selected 12 literatures which I have referred, in the reference list also. And these 12 literature, I am just going to introduce them in very short form because their content will be discussed later on also. And here the method of literature selection is exhaustive selective coverage, and it is based on the Cooper's concept. And I have discussed about those literatures in this work, and they are Ferrari and Kai 2006, which is about basically how naive explanation works in explaining biological theories like natural selection of Darwin. And another is Greeks. This paper is very introductory for like scholars or students like us who want to do social science research. It's about basic components of research. Another is Kelly and Spohr. That is about naive theories about effects of mood. Because when we talk about mood, if there is a large scale of crowd around, then what kind of naive explanations works and how can we measure that kind of mood effects in very scientific way. That is another way of discussion. And another is Osho. Actually, I have presented about this little bit in earlier class also. That's why I don't want to go on that. McCloskey and Cole. And this work is about physics, because this naivism is not only social science, it is very relevant in general science or natural science also. That's why in this paper it is discussed in the case of physics and particularly in inertia. And after that, in this another work, science students also have different kind of views about scientific process. It is called NOS, Nature of Science. In this study, that has been discussed. And after that, naive and informed views on the nature of scientific inquiry, as I just mentioned, but of it in large scale. And this is another work about again basic concepts of research, that is research methods for business students, and Saunders et al. This is about. And another is Stallman work. His work is basically about qualitative difference between naive and scientific theories of evolution. And another is Smith work, that is defining versus describing the nature of science. It is how to describe nature of science, NOS. And the content will be discussed down below. That's why I am not going on that. And after that, Watt and Burt's work, that is about research methods for communication science. Actually, this material is provided by Sir only one book chapter. This is, I have referred here a book, whole book, but Sir has given us only one chapter of it, the introductory chapter about science and naive science. After that, another is Williams' work, that is Nature of Science and the Role of Knowledge and Belief. Here particularly I will be discussing how knowledge is different than belief, and belief should be differentiated from knowledge, otherwise it will be very confusing while we talk about science. And here are these components of science. Actually we have discussed about these earlier also, but when we talk about science, these components should be there. Empirically testable data. If we cannot test any concept, that is useless in science, that is not considered as science. Another is replicability, or it is also called repeatability. And another is fallibility or tentative. That's why there is always error, sampling error, margin of error, we say there are others also, non-sampling error also. These all theories, concepts are related with this, and it is self-correcting. If there is a new concept and new evidence particularly, it is always considered to be corrected again. And here I have taken another topic, that is some features of or values of science. Actually, this author called Smith has clearly mentioned values, but I put it in bracket because often we say science should be valueless. Better represented that term by features, because values may be confused with the basic notion of science. That's why I have done this. And these basic values are theory-based, predictive, fecundity, new questions, parsimony, logical, and skepticism. And I think theory-based I don't have to mention. Predictive also I don't have to mention because it is about very basic foundation. It can predict the events or sequence or anything like that. And fecundity, that is new questions are always considered in science. Parsimony, this term may be new for you or may not be, but parsimony generally refers to to be very simple and understandable. Science concepts should not be very like broad and very like mathematical and very like contents which cannot be understood. For example, Newton's law is very simple. Newton's law of motion or gravity. And similarly, science should be simple like that. That is the parsimony. And another is logical and skepticism. Skepticism, actually, we do hypothesis testing in quantitative studies. Actually, we sometimes be skeptical in science, and mostly, not sometimes, mostly, that is, we try to avoid the new like concepts and try to stand in the original concept. And when we have sufficient evidence, then only we move towards the new concept. The similar works which are related with the basic concepts of science or elements of science I have included here. And this is I have taken actually by Miller et al. And he has referred these all different authors. And basically it talks about human endeavor. Science is always initiated by human, though natural processes are ongoing. But ultimately that science is applied by human being and contextualized by society and culture. Sometimes we think that science is very independent of society, culture, or whatever other views or like society norms and everything. But we should not think in that way. At least Miller's, these all authors which are cited here, they say that. And after that, another term which is relevant with science, that is non-science, particularly Smith has used this term. If there is any kind of authority, then that is not science. Like, for example, political leader or religious leader say something, or any government official say something, and we should accept that that is not science. So it is always authorized by evidence only. What evidence is, that matters. Similarly, theology, which is the branch of philosophy which studies about God and religious belief and everything. And this is also not branch of science, it says that. And another is faith-based. I don't have to explain because it is very similar to this earlier one. Now I want to come to the next part of science, that is foundation of scientific inquiry. Ontology is the beginning point of any science, that gives us an answer of a question like what is reality, and it is basically categorized into two categories. After that, epistemology comes. For example, in Greek's work it is categorized in two categories, but Saunders et al. Have defined it as realism as another category also. Similarly, there are these other steps which are like approaches, methodology, methods, data, analysis, interpretation. I don't have to go through them all because we are all familiar about this terminology. And if you want to visit the original materials from where I took this, you can visit Greeks and Sanders' work. And after that, I want to come to the main point, which may be a bit new to us, that word itself. Actually, naive means like being very like innocent or not scientific, to be honest, but it is represented by different words like lay. That is, you know that lay, we say layman, no? It is exactly the same thing. Implicit, intuitive, or common sense, like what we think our mind, that is naive science. And after that, organized knowledge and beliefs. Actually, knowledge is science. Knowledge comes from scientific process, but if that is connected with everything and we are not going to break that and we just leave it as a bulk, then that is not science. The Wagner and Balazar's like point of view is that. And after that, beliefs are not science. After that, where those naive theories are applied, like in the case of self, leadership, relationship, stereotypes, and similarly in the general science or natural science like mechanics, thermodynamics, acoustics, which is related about sound science, similarly physical chemistry, cosmology, which is about the study of the universe. And this is the answer of the first question. Now I am coming straightly to the second question, that is how to differentiate true science and naive science, because if you cannot differentiate between those two, then we cannot do a scientific study. We may be affected by naivism. Well, first of all, I want to thank you very much, Manojji and Ritaji, for your comments from both positive side, strength, as well as some areas to improve. It is obvious process that if we do something, there are two ways, to consider it. And first I want to come to Manojji's point. Actually, Manojji has made many points and I have noted some of them here in very bullet point. And among them, first of all, he has talked about presentation, mentioning about presentation. That's very valid point, Manojji. I don't disagree with you in that matter. We should clarify in the beginning. Actually, I wanted to go here a little bit, but because of time limitation, I a bit skipped. Relating to research question, you have said that there are many questions. Actually, there are 3 questions, and I just very kindly remind you that we are going to write paper also. That's why this presentation is just one introduction only. In paper, we have a lot of scope to answer these questions. And relating to literature selection, there are many literatures, and there are others also. For example, you discuss about Karl Popper. Actually, I have not taken Karl Popper here directly, but I have taken those literatures which are worked on Karl Popper, and the demarcation or let's say differences which I have put in this table, actually that is the basic points are these only. Karl Popper is one which I have also studied like in the past very much, and I like his theories, particularly of falsifiability, which is his perspective in science and contribution also. One of the main point you raise is here is like in short time it became a bit very much content. We have this time like insufficiency always, dearth of time, and that I try to compress it. During that process, some concept I may not have explained in detail, but still I will be forwarding this you all scholar friends. Then also you can feedback me, because I expect then also your feedback. It has a wide scope for me to improve then everything. I think I came to all points of Manojji, and Ritaji has raised the question of naive and experimental. I have not found any literature where naive science is defined as experimental science, but it may be the case that during experimentation, there it may be that how naive factor plays the role. That may be the case, but naive science itself is not described as experimental science. Thank you everyone.